F and G, this one's already been drawn for you. So on your calculator, where they ask you for F, just put this one. You don't have to make sure the letters on your calculator match. Okay, now when it says start, where are we going to start? Here, so minus 180. Where are we going to end? Over here. So we're going to say 180. Now step, we would normally say period divided by 4. However, we can see on this here that they've given us the step. We can just use 45 steps because we're jumping in 45. So put your step as 45, and now you should have all of your values that the calculator gives you. So if you've done it correctly, you should have these coordinates like this: minus 135, 0, minus 91, minus 45, 0, minus 1, 45, 0. So now we're just going to go plot. So minus 180 and minus 1 is here, and minus 135 and 0. This is pretty straightforward. Hey guys, you would understand what to do. Okay, now we're going to try draw a nice graph through all of that. All right, so there we have our graph. Now, let me just make sure we've done anything. Clearly show all the intercepts with the axes. Okay, so let's just I guess label it 0, minus 1, 45, well, that's negative 45, negative 90, 1, and then negative 135, and then negative 180. Okay, clearly show all the intercepts with the axes and turning points of the graph. Done. Now it says, write down the period, this. Okay, so what we need to understand about period is it is something to do with, now in an equation, if you say, for example, let's say you say, for example, h of x is equal to f of x plus 3. That plus 3, for example, would... Okay, I need to stop saying for example. Kevin, we get it. It's an example. Okay, guys, so you know that this is an example. So when you have a plus 3 there, does that affect the y's or the x's? That only affects the y's. If I say, for example, okay, I got to stop saying that now. If I say that t of x is equal to 3 times h of x, then by putting a 3 in the front, does that affect the h? I mean, does that affect the x or the y's? That also affects the y's. Okay, so then what affects the x values? The only way to affect the x values would if you have something like that. Let's say r of x is equal to w of 2x. You see, now I'm putting the 2 with the x. That would affect it. Or if maybe you have something like this, is equal to n x minus 20. You see how this affects the x, this affects the x. So this little 2 in the front here does not affect anything. Okay, now what does this do to a graph? Well, what that does to a graph is it moves it 10 degrees left. So by moving a graph left or right, that doesn't affect the period. Remember, period tells us how long does the graph take to make one repetition. For example, if I have a graph like this, and I know that this is 360, then I can see this graph is repeating one cycle in 360. So here you would say period is 360. If I then had to take that graph and move it 10 degrees to the right, everything would move 10 degrees. So this would now move, this point would now move to here, and this point would now move to here. But the graph wouldn't be stretched or compressed, so it wouldn't change the period. So this part does nothing, and this part is doing nothing to the graph. So what is the period of G? So it is a cos graph, but you got to be careful. If it is a normal cos graph where you just have cos, then it has a period of 360. That is the same for sin as well. If it is tan, then it is 180. Okay, so a normal cos graph is that. When they put the number 2 over there, or any number over there, then it changes the period. Remember that the standard equation for a sin, cos, and tan graph goes like this. Now remember, this k value, which is with the x, changes the period. So to work out k is always equal to the original period divided by the new period. So we know that k is 2. We know that the original cos graph, like a normal cos graph, is always 360. And now we're trying to work out the new period. So you need to now solve this. And what you should eventually find is that the new period is going to be, so the period of this graph is 180. Why am I saying new and normal? When I say normal, I'm talking about a normal cos graph that just has cos x. Now, the new one is this one over here that we're busy with in this question. And that 2 over there is going to cause the period to now be 180. So it says write down the period of the graph when you do this and this. Well, this and this don't do anything to the graph of G, so it's just going to be this question. Now remember, we still have 2 more questions coming up, okay? Now it says here, use the graph to determine the value of x in the interval 0 to 180. Okay, so they only want you to look between 0 and 180. So we're actually going to block off the rest of the graph. So I've tried my best to just block that all off. So it says use the graph to determine in that interval. So just in this little area over here, where is this? Okay, so it's one of these questions where we have f of x multiplied by g of x, and they want it to be negative. So what we do, what I always do in these scenarios is when you multiply two things together, how can you make the answer negative? Well, the one way is if f of x is positive and g of x is negative. The other way is if f of x is negative and g of x is positive. So let's look at scenario 1. Let's look at this one. So what we'll do is we'll start here. Where is f? Well, f is positive. The graph of f, by the way, is the original one. So that's positive. Positive means above the x-axis. Now so now in that interval where that is true, is there any place where g is negative? Well, g is negative there. G, when it's negative, it means under the x-axis, and this is the x-axis. So now, is there any place where there is an overlap? Yes, the overlap is here. You see, that's where the overlap is. So what are the x values of that overlap over there? Well, it's from 0 up to 45. That is where you can see the yellow and the green are overlapping. And so like here, there's no green. So that's our first answer. X is anything between 0 and 45. And we actually can include because they have also included. Okay, and I will show you interval notation as well just now. Let me just do it now in case any of you are like, so I'm freaking out. Okay, now that's just the first part. Now we need to look at this scenario over here. So let's reset all of this. So now we need to look, where is f negative? F is negative over here. Negative means under the x-axis. And then where is g positive? Well, that means above the x-axis. So that would be, so where's the overlap? Where do you see green and yellow above each other? Well, that would be, so from 90 up to 135. So from 90 to 135, and then you could say x is an element from 90. So when you give your final answer now, you could say that x is an element from 0 to 45, from 90 to 135. If you prefer set builder notation, you could say x must be anything between 0 and smaller than 45. X must be anything between 90 and 35. Now, with these two last questions, this one says, write down the maximum value of fx minus gx. What you need to understand about fx minus gx is it's taking the y value of f minus the y value of, so what it actually is, it's the vertical distance between the two graphs. So for example, if f of x is over here and it has a y value of 4, and g of x is here and it has a y value of 1, then if you minus them, if you say f of x minus g of x, so we want to look on this graph, where do we see the maximum vertical distance? And if you look carefully, it's going to be here. Okay, that is the maximum vertical distance. We can see that the y value here is 2 and the y value here is minus 1. So what is the vertical distance going to be? It's going to be 3, right? Because this from here to here is 2 and from here to here is 1. So 2 plus 1 is 3. So that's the answer, 3. This one says determine the range. Okay, very easy. All you're going to go and do is just go find the maximum value that this can be, and then you're going to go find the minimum value that this can be. So we're going to go find the maximum, okay, of 2 to the 2 cos x plus 2. And then we're also going to go find the minimum of 2 to the 2 cos x. So to find the maximum of this, got nothing to do with the 2. That can't change. All that changes is this. So, and this can't even change. Not even that part can change. So let's actually just look at this, which is the graph that we were given. Can you see that it is the original graph we were given? This part here is this graph. Where is that graph a maximum? Well, that graph is a maximum up here at 2. So the biggest that this number can ever be is 2. So it's going to be 2 to the power of 2, and then this plus 2 is just there. You can't change anything there. So it's going to be 2 to the 4, which is 16. Now, if we look over here, what is the minimum value that 2 cos x could be? What is the lowest value you see? Well, I can see it comes all the way down here to minus 2. So we could change all of that to minus 2, and then you still have plus 2. That's going to give you 2 to the 0, which is 1. And so the range is going to be 1 to 16, 1. But the proper way to write it would be like this if you are doing interval notation, or you could do it as that if you're doing